Today, the speaker is Laura Ricci from University Pisa in Italy, with her talk, Blockchain for COVID-19 Contact Tracing and Vaccine Support. Great that you're all coming in today. This cafe session is a cross-project collaboration between the Horizon 2020 European research projects Helios and AI4EU in the current Next Generation Internet program. My name is Carmen McWilliams, and I'm the moderator and organizer of the cafe. I'm the director of the company Grassroots Arts and partner in the European AI4EU and Helios projects. So, welcome everybody. Please take notice that the session will be recorded. The recording of this live web session will be available afterwards on request. No confidential information shall be shared in this cafe session. In this cafe, the speakers express their personal view and opinions. This is not necessarily the official AI4EU or Helios project opinion. So what is this AI4EU Café about? It offers a series of live web sessions with great speakers. The cafe is an online forum to gain insights into the European AI next generation internet scene, participate, get the chance to share knowledge and experience, and meet stakeholders from various areas of AI research and application. I see you all coming in. Great. Thank you that you're here. And now also, hi Laura. Great you are here. Hi Laura.
Hi, thank you. Thank you.
Thank you. Pleasure you're here. And I will introduce you now to the great participants in the cafe. Laura Ricci received a PhD from University of Pisa. She's currently associate professor at the Department of Computer Science, University of Pisa. Her research interests include distributed systems, peer-to-peer networks, cryptocurrencies, blockchains, and social network analysis. In these fields, she has co-authored more than 150 papers published on international journals and conference workshop proceedings. She has served as program committee member and chair of several conferences, and she is editor of international journals on blockchain technology. She has been a member of the group for the definition of the Italian national strategy on blockchains, and she has been involved in several research projects and is the local coordinator of University of Pisa unit of the H2020 European project Helios, a content-aware distributed networking framework. And Laura says, please contact her afterwards if you need further information. And now we're coming, of course, to the main reason we are all here, to Laura Ricci. Hello, Laura. And this will be an interactive session. If you have questions to Laura, write them down in the text block. It's like on the right side, it's a text chat. You can write them down and I will read them afterwards to Laura. So now I will change the presentation role to Laura. And the floor is for you, Laura. Yes, I see it. Great.
Okay. Okay. Perfect. Okay. Let me. Okay. So. Sorry. One moment. Just one moment. And I have to.
Yes.
Okay. So thank you, Carmen, and thank you really for giving me this opportunity, and thank you to all the persons who are following the presentation. I don't see them, but I thank everyone that comes here to listen to me. So the presentation, the presentation of what I do is has already been done by Carmen, so I can go to the presentation. So I have to speak today about blockchain, and in particular application of blockchain for COVID-19 to support, to face the problem of COVID-19. But first, I would like to give you, because I don't know who is listening, a brief, very brief presentation of what is a blockchain. You know that blockchain are really very popular today. Anyway, I will give a brief introduction to this technology before looking into the possible application of this technology in the area of supporting solution for COVID-19. Like the name says, a blockchain is a chain of blocks that contains information. Actually, it is a ledger, a distributed ledger that is replicated exactly the same ledger version on the nodes of a distributed system, generally peer-to-peer network. And it has a very interesting property. Once some data has been stored inside the blockchain, it becomes very difficult, I can say computationally infeasible, to change the data. And this, as you can imagine, can be exploited, for instance, to timestamp digital documents, so that it is not possible to backdate a document, to tamper with them, almost like you do with a notary ledger. So let us give a closer look inside a block of a blockchain. Each block of a blockchain contains some data, the hash of the block and the hash of the previous block. As you will see, hash is everywhere in blockchain. It is a basis of the blockchain. And which kind of data is stored inside a block depends on the type of a blockchain. For instance, the killer application for blockchain, which is the Bitcoin blockchain, store details about a transaction of a monetary transaction, and store, for instance, the sender, the receiver of the transaction, and the amount that is transferred, for instance here, from Mollis to Bob. This is not the only application. This is a killer application, but not the only one. For instance, generally, you can use blockchain as a log to register the events that happens on a supply chain. For instance, there are very complex supply chain. For instance, here we have a farmer producing a product. And then you have the producer that have to certify the product, the distribution of the product, and finally the retail selling the product. It is possible to use the data, in this case, the data inside the blockchain are all the events regarding this complex process, supply chain. The second element inside the blockchain is a hash of the block. You can consider a hash like a fingerprint, because it's like a fingerprint that identifies the block and all its content, and it is unique for each block, like a fingerprint that identifies you. And when the block is created, the fingerprint is calculated, and you know, as you have seen, the hash is of basic importance, is basically important for a blockchain, and it has some nice property. For instance, an hash function is a one-way function, meaning that you cannot go back from the hash to the data that produced the hash. It is also the property of collision resistance, a lot of mathematical properties which are very fine and are used to define the blockchain. And you see here that even a small change in a block, here we have this kind of yellow part in the block, it's a change in the block, but even a small change inside the block will cause the hash to change completely. And so you can deduce that hash are very useful if you want to detect change in the block. The third element of inside each block is that each block stores the hash of the previous block of the blockchain. So this is what create the chain of blocks. The chain that are represented here are hashes. Every block contains the hash of the previous one. This is an example of 3 blocks where in each block is stored the hash of the predecessor block, apart the first one, of course, that has no predecessor. It is a genesis block in general. And so when suppose now that you tamper with a second block, an attacker change something in the second block, this causes the hash of the block to change as well. And in turn, the hash of the following block will change, and because it does not store no more a valid hash, and so changing a single block will make all the following blocks invalid. This is enough. This is not enough to prevent tampering, because computers currently are able to compute in a very fast way thousands of hashes per second. So you could also tamper with a block and recalculate the hash of all the block of the blockchain, and this is not enough to guarantee tamper freeness. So the idea to secure a blockchain is, and to guarantee a high level of security, is to put in the block the proof that you have done a large amount of computational work to produce that work. That is called, for instance, proof of work in the case of Bitcoin, but other blockchain may use other different mechanisms. So you don't have only, if you tamper, if you change a block, you don't have only to change the hashes of all the following blocks, but also to redo the work for each block, and this is computationally infeasible. So, another important property of the blockchain is that the management, the governance of the blockchain is distributed. There is not a single entity deciding which block has to be added to the blockchain, but there are a lot of nodes that participate and in the consensus, as the consensus is a mechanism that, as is explicit by the name, is an agreement on a common decision that all the nodes of the peer-to-peer network has to take. And so also this is another security important characteristic, because there is not a single node deciding what to do with the blockchain, but that you need an agreement between a lot of nodes. Of course, this node, the blockchain may be completely open to everyone, and this is the model of permissionless blockchain, but you can also restrict the governance of the blockchain to in some way. But in any case, it is a distributed system. It is not more a system based on a single server or something like that. After this introduction, let us come to how blockchain could be used in contact tracing and in vaccine certification. First of all, let us briefly introduce, before introducing blockchain-based proposal for contact tracing, proposal because they are proposal made in the last, 9 months, while there are, existing tools for performing contact tracing which are not blockchain-based, and that has some problem, as we will see. So the current approach can be broadly classified as follows. We have the proximity-based contact tracing application apps, which are based on detecting the relative position of two users, of two smartphones that comes in close, that are near each other. Most of these apps use Bluetooth employs Bluetooth low energy technology, and there are protocols defined like PEPP-PT protocol or DP3T protocol. There is also location-based contact tracing that, instead of using the relative position, use the absolute position of the smartphone using GPS or Wi-Fi connection. The main drawback of this solution is that the low level of security and serious privacy problem that can arise when your users are traced. That these problems are also present in the previous proximity-based contact tracing. Finally, we have a solution that exploit mobile operator infrastructure like base station of cellular phones. Of course, these are only proposals. I do not know about real implementation of this kind of proposal. But you can find several proof of concept and proposal in this area. If you consider proximity-based contact tracing, the first model, which is the PEP-PT model, this class of solution are those where users register to a central server and the user centrally generate a set of temporary identifiers which are encrypted with its secret key and send this identifier to the user. The identifier are then exchanged between mobile phone using Bluetooth, and when a user gets infected, its or his or her identifier and the identifier of the other user came in contact with it are uploaded on the server, and the server sends the warning notification. This solution is used, for instance, Trace Together, COVID Safe, Stop COVID. There are solutions in this area, several solutions in this area, but the solution arises severe privacy concerns because the server is able to decrypt, to see all what happens, the identity of the individual, to trace the individuals. The second model, a better solution from the point of view of privacy, is that of DP2T model, where in this model, the identifiers, the unique identifiers, are autonomously generated by the mobile phones and are stored on the mobile phones. So there is no intervention of a central server in the generation of the identifier. They are exchanged by, between the mobile phone, generated, exchanged between the mobile phone. And however, a centralization point still exists because the user that gets infected upload its identifier, its pseudonym, to a central server, and other user periodically download the identifier of the infected person from the server and compare them with the identifier that they have stored on their mobile phone. So in this case, the server is like a rendezvous between the infected user and those users that he has contacted in the previous 14 days at most, because the incubation period of COVID is 14 days. There are some issues. Most of these proposals have failed to reach their goal. Why? Well, this is my personal opinion, because I think that contact tracing is a real complex process. We should require a strict connection, coordination among different entities, which are developers, health authorities, citizens, laboratories. While, at least in Italy, we have had 1 year ago a great debate on privacy issues of this application, but what lacked was a real governance and the proper support to facilitate interaction between actors involved in the project. And there is also a lack of incentivization for citizens to use this app. So for they have failed. They are there. We have here in Italy an application for contact tracing, but they have not worked well. So blockchain may solve this issue. This is, of course, a question. And but what are the characteristics of blockchain that would be interesting to help in this area? Several characteristics of this technology may help. First of all, replacing the centralization point with a blockchain, of course, will increase the level of transparency in the process, because you can monitor several processes directly on the blockchain, and it could also enhance the interoperability among different actors by providing common interface among them, so simplifying the processes and reducing the cost. Blockchain, as I said, good. Now, okay. In any case, I will try to go on with this presentation. And I was thinking, I was telling about the proposal which are blockchain based, which have been proposed in the blockchain area. You see here a taxonomy of the proposal, and you see that I have reported here only the most important proposal that are classified. There is a taxonomy of the proposal. You see that they are classified. The blockchain-based proposal for contact tracing, they are classified according to the communication infrastructure that may be Bluetooth, GPS, cellular network, to the cryptographic techniques they use, to the party that they involve, and also to the blockchain type they are using. For instance, if they are using the blockchain role, if they're using the blockchain as a bulletin board, as a location or as data vault or something like that. And also so the type of blockchain they're using. You can use a permissionless blockchain, as I said you before, where the governance of the blockchain is completely open to everyone, and a permissioned one where the governance of the blockchain is restricted to only some actors. So there are a lot of proposals. I have no time, of course, to show every proposal, but most of them, as you can see here, replace the central server, which is used by contact tracing proposal centralized application, with a blockchain. For instance, you see here in the left part of the figure a user, for instance, which is Olis, for instance, which is visit several locations, for instance, home, the bus, and then go to work. And during this period, Olis meets several persons. And later, in the right part of the figure, you see that Olis is detected infected, and in this case, it will have to all that location will be marked as at risk. And the idea is that Olis upload on the blockchain it's the identifier that its mobile has generated in a period of time, in the last 14 days, and the other people can download, look at the blockchain to see if there are some identifiers for blockchain which correspond to the identifier they have stored in their mobile. What about privacy? This is a solution. Okay, simply replace the central server with a bulletin board. Okay, which simply store the information that before you stored on the server. And but there are a big problem of security. The privacy of this solution may be increased by using, for instance, randomized addresses generated by Bluetooth. There is a mechanism to generate a set of random identifiers that are frequently modified by the Bluetooth protocol. And of course, there is a trade-off, because the more identifier you generate, you increase the traffic, the number of information exchanged by the mobile phone. However, also this solution presents severe privacy threats, and is subject to massive surveillance attacks. And for instance, one of these, I present one of these here. Imagine that I want to perform an attack which is targeted to a particular person. I know the habits of this person, and this person, for instance, visit home, then takes his or her children to school, then visit a cafeteria, a bar, and then go to work. If I am an attacker, I can position Bluetooth devices on the path, on the travel that the person performed from home to the work, to collect its identifier, the identifier that it's mobile exchange. And this is a problem. This is a simple attack, but you can also make more complex attacks, really big surveillance attack. And the idea, one interesting proposal in this area is to use a Diffie-Hellman protocol. It is a cryptographic protocol which is used when you have two entities that are connected through an insecure channel, and you want to share a secret that is only known by the two parties, but it is not known by third parties. It is based on computational algorithms of discrete logarithm secret group, but it's not important. There is a mathematics behind. And their basic idea is to replace the generation of users' identifier pseudonyms with that of unique encounter identifier. So instead of having identifier that everyone can take, you use identifiers that are a secret of only the two parties that have been met. They are known only by the two users that have met. It cannot be taken by an attacker. This is a picture I have taken from Wikipedia, but it is really gives the idea of the Diffie-Hellman protocol explained through colors. Here, Diffie-Hellman is like that. You have Alice and Bob. They agree on a common color, yellow, for instance, and then they have a secret color that is red for Alice on the left, and blue-green for Bob on the right. You mix the two colors, they mix the two colors, the common colors with the secret color, obtain a mixing, and they exchange this mixing, and then each of them mix again the mixture that has received with its or his or her secret color. At the end, they obtain the same color at the end, but only them are able to know that color, no other one. So an attacker is not able to understand what is exchanging, what is a secret that is known by the two parties. There is a proposal, interesting proposal of using the blockchain to upload on the blockchain this kind of encounters identifiers. So user can upload the user that is detected infected can upload on the blockchain the identifiers, but each of these key 1, key 2, key 3 is only understood and can be only understood by other parties that know the secret, but not all from all the other one. So this is an interesting solution putting together blockchain and cryptographic techniques to enhance the privacy of the current solution, also centralized, but also it is you are able to exploit the blockchain as a bulletin and be sure from the point of view of privacy. The last part of my presentation, I will try to be short because there has been that internet disconnection, is that of immunity and vaccination certificates. Immunity and vaccination certificates report different aspects of the user health, because immunity tells you that you are immune, perhaps you have taken COVID-19, you have the anticorps for COVID. Vaccination, instead you have got a vaccine. So there are in literature proposals of distributed solution for certification, which are mainly based on two concepts: the concept of the centralized verifiable claims and the concept of self-sovereign identity. The centralized identifiers is a standard which is the W3C verifiable claims working group is working to standardize these documents and for distributed certification. But the main idea is to define a new idea of public key infrastructure, so to replace the classic public key infrastructure with a blockchain. Strictly related with this concept is the concept of self-sovereign identity. The idea is that you have to control this decentralized identifier is managed by the user through its private key, so the user accumulate credential claims in their accounts that are like wallet, a wallet where you can put your credentials that you have obtained from certification authorities and from different authorities, and use then this credential to prove something to the verifiers, revealing the minimal amount of information necessary for the verification. So you are an owner of your claims, and you can show your claims to whom you want. You can show a part of the claim. You have the ownership of this claim. For instance, it is a typical situation where you have, for instance, an health authority, which is the issuer, that signs claims. For instance, the health authority is a laboratory giving you the vaccine and sign a claim, and you have then so the issuer of the claim, you can collect the claim in your wallet, countersign this claim. For instance, the holder of the claim are citizen, worker, student, tourist, whatever you want, and then you present your claim to a verifier that can be, for instance, the authority in the airport, for instance, border patrol, a train controller, whatever you want, that want to verify that you have been vaccinated. But where is a blockchain? The blockchain replaces, in this case, is like a ledger, a bulletin that store your identifier and your public key, so that everyone, you can sign your document, and everyone with your public key can verify that the document is authentic, can authenticate the document. The role of the blockchain, so it is to register the correspondence between the distributed identifier and the public key. And so takes the role of the certification authority. It has several benefits, auditability, scalability. An interesting thing is, for instance, identity retention, which is preventing the user. For instance, identity retention is a problem of current centralized certification authority, because it is often the case that you have to prevent a user from registering and already registering an identifier, a public key that is originally registered. So it may solve several problems of current solution. There are existing CE systems already which base the certification on this blockchain. For instance, Sovereign is a system developed on Hyperledger. Uport is developed on Ethereum. They are, of course, for the moment we have only proof of concept. I want to show only a proposal, then I will conclude. It is an interesting proposal by Open University. The link is in bibliography, which puts together this technique of verifiable credential and distributed identifier, the Ethereum blockchain with a smart contract to store this correspondence between your identifier and your public key, and Solid, which is a decentralized personal data platform, which is Solid and SolidPod. It is a project by Tim Berners-Lee that the idea is to give the ownership of the data again to the user. So I report here the graphical abstract that I have taken from the paper, where you have for here the mobile phones of the user. You see here the same situation of before, the holder of an identity, and the various steps I showed you before. But for instance, you can store the vaccination certificate, your certificate, or your private pod, solid pod is called in this case, and you can put your data wherever you want. You can take on your mobile, you can have a personal cloud, you can also put on a distributed file system. For instance, the project is similar to another famous project that is IPFS, that is a project to decentralize the web, decentralize data, so that everyone is again owner of its data. And the blockchain is used, of course, like a repository, a register to register identities. But for instance, you can also put on the blockchain, you can take by yourself the certification, but you can put on the blockchain the hash, for instance, of the document, so that it is possible to prove the authenticity of the document, that the document that has been released from the authority to you, you don't have changed it. And the proof is an hash, which is stored on the blockchain, which is publicly accessible by everyone. It is a structure that everyone has because it is replicated on every computer. And so you have these benefits. So let us go to my conclusion. I think that it is blockchain is a promising technology. It will increase transparency, auditability, interoperability, but I am aware that several issues have to be solved. The problem, there are problems because the throughput of current blockchain has to be increased, and latency has to be decreased. You have also to solve legal and societal challenges because this new technology really to be, in order that this new technology has to be really accepted from the community. But I think that also there is a trade-off between privacy and auditability, but there are also several solutions, I think, that try to solve this problem. We are aware that in the last year, several new consensus algorithms have been proposed that can increase the throughput of the blockchain, and there are a lot of other proposals after Bitcoin, after Ethereum, but we have another novel consensus algorithm. For instance, Algorand is a good promise in this field. You have also a lot of new cryptographic tools, new and not new, but applied to the blockchain. So a lot of privacy preserving cryptographic tools like zero knowledge, multi-party, blind signature, and so on. So I think that it is it is a technology. Bitcoin is 12 years old, but it is 5 or 6 years that they are trying to apply this technology to areas which are different from cryptocurrency. And so I think that we are doing a lot of work in this direction. Finally, the reference that I have used in this talk, the first one is a review that I have co-authored this paper together to colleagues from Link Torino, that are Enrico Ferro and Alfredo Favenza. We have worked together, and together Damiano Di Francesco Mesa, who is now is a researcher at the University of Pisa, coming from Cambridge. And the other two references that I put are the first one is the solution for vaccination certification I presented in the last part of my talk, and the last one is the solution proposed to use Diffie-Hellman protocol to increase the privacy of current solution for contact tracing, and to exploit the blockchain together with contractation apps.
Thank you. Thank you very much.
Okay. I am happy that you were able to hear me, because I was not sure that our Wi-Fi works. Okay, thank you. Thank you.
No. Yeah. Thank you very much for your great presentation, and you came also back. Oh, that was good.
I am so sorry, but it was not. I wouldn't. Okay, this is a the problem here in the department.
Yes, the first practical question is, do you share the presentation with us? I mean, also with the participants. Would you share it?
Yeah, sure.
Would you send it to me? Because I promised to some of the participants who left, it's like 2, 3,
yeah,
to send it to them. Is it okay?
Yeah. I will send you the presentation. I will send you. As soon as we finish this session, I will send you the presentation.
Great, and whoever who's still listening wants to have the presentation, drop in an email, please, because then I can send it also to you. And my first question here to you, Laura, is do you know, I mean, for example, in Italy or anywhere in Europe already an existing application on blockchain for vaccination or for testing or for contact tracing? Do you know one? Is there one out there?
I am especially aware of a situation here in Italy, because I belong to the National Committee for the Strategy of Blockchain. And just 1 month ago, here in Italy, there is an initiative which is called the IBSI. Okay, they are setting on some nodes of blockchain, a public blockchain, so a blockchain which is shared between public organizations, universities, ministers, and other public actors. They are working on Hyperledger as a blockchain, but I think that at least at the best of my knowledge, they are not developing vaccination application on that. For the moment, they are working, for instance, to exploit this blockchain for supply chain, for instance, to certify made in Italy, product of made in Italy, that is very important for Italy for that, and also to certify diplomas of students coming in Italy for Erasmus project, but not for vaccination. This kind of infrastructure, Italian infrastructure, will be connected to the EPSI, which is the European infrastructure for blockchain. There will be a connection between different blockchain. And I am not aware of initiative in the, but I know that they are working on self-sovereign identity. So vaccination is really connected to self-sovereign, because you need something that give you a certificate, and you have to manage that certificate, to present the certificate to whom want to check your status, no? And they are exploiting that kind of, for instance, sovereign is very popular, and I think that it's working in some sense. It is one of the use cases, most interesting use case, and I think that developing certification, I don't know if COVID the certification, but a certification system on that blockchain.
Okay, great, thank you. And I want to hear from Nuria. I think this is not a question, there's some information for you all. Nuria Sala, in our UNIT is UNID Foundation. We have got ready the solution based on blockchain, and in our universal health identifiers patented. It's for vaccination, certificated laboratories, tests, etc. We are offering to any institution to test it. So if anybody's interested, UNID, UNID, no? Foundation. And here's a question from Ana Maria Morales Perez. We know, hi Anna, is Helios project considering developing an app for contact tracing? That's the question. Is Helios project considering developing an app for contact tracing, she asked.
Okay. Helios project, as you know, Carmen, but for the other people, is strictly connected to this idea of decentralizing data. No, Helios is mainly focused on social network, building a social network, distributed social network. But I think that there are a lot of similarities in Helios. Do you hear me? Do you hear me?
Yes, but you're slowly fading, so yeah.
I may. Okay. Okay. And I think that we are very close. So I think that many of the techniques that we are developing in Helios are similar, for instance, to the technique I presented of the pods, the project of T. Berners-Lee, where you have your data and you take your data with you in your mobile or in private cloud. It is really similar. So we are focusing in Helios on social network, but I think that we can develop something similar, or at least the result of the project can be exploited in this direction. I am pretty sure, because the problems are similar. Okay.
Yeah. Okay. So it's also coming now 4 o'clock. So I want to thank everybody, but especially you, Laura, for being here. And thank you for everybody who stayed with us. It's basically 90% stayed with us. Great, thank you.
I thank you for your patience and for the patience of all the audience. I am very sorry of this this problem.
No problem, because it wasn't sure, and it wasn't your fault. I will cut out this little break in the recording, and afterwards send you the recording.
Sure. Okay.
Yes, thank you very much, and see you hopefully one day again in person when this drama is over with the pandemic. But until then, thank you for being online, and see you soon. Bye bye.
Thank you to you, to all the audience. Bye bye. Bye bye. Bye.